Hello friends, welcome to Catalyst Chemistry. As we discussed last class, important point about what mass number, next one is what, that is isotopes, next one is what, isobar, the next one is what, isotones. Okay, you know very well about that. Isotopes means that is having a what, same atomic number but different mass number, but isobar is completely opposite of what, isotopes. In isobars means what, the different atomic number but same mass number. That is why in this case isotopes and isobars, these two are what, completely opposite. The next word is what important, what is that, isotones. Okay, isotones means what, in this case same number of neutron, that is indicate what, isotones. Compulsory you know the what is the atomic number of this element and mass number, at least make it practice up to 30. That is, if you know entire periodic table, it is a better for what, entrance exam. In theory exam compulsory you know what, up to 30, make it, you have to write atomic number and mass number, make it practice. Okay, that is most important. In neutron, in isotones means what, that is same number of neutrons, but last class one mistake, okay, I did one mistake while writing. Just here in this case what, carbon 614 is there. The next one is what, nitrogen 714. I wrote in a last video that is 714, make it correction, that is what, 715. In this case just you have to write 715, after that what, in this case oxygen 816. Make it minus, 14 minus 6 we are going to get a 8, 15 minus 7 we are going to get a 8, 16 minus 8 we are going to get a 8. Okay, that is why in this case what happened, the same number of neutrons, if same number of neutrons having a different elements, just here carbon is different, nitrogen is different, oxygen is different, different elements having the same number of neutrons, that is called what, isotones. Okay, please make it correction, make it last class what I did, that is 14, no, make it correction, that is 15. Okay, is it clear? Okay, next important point is today we are going to discuss the next important point about what, electromagnetic radiation. Just see here, the next point is wave nature of light. Student, please listen here. Light is having a dual property. One is what, particle, another one is what, wave. Try to understand. Wave means you know very well about that. If like this is there, that is indicate what, wave. Particle means how we are going to understand a particle. Particle means try to understand analogy as like a bullet, as like a what, a bullet, that is indicate what, a particle. Bullet move straight. Okay, bullet not move like this, bullet is always move in a what, straight. Just here in this case I am going to write, okay, this is what, one scale is there. Okay, the light is, this one is indicate what, waves, this one is indicate what, wave. Bear in mind, light is having a dual property, one is a wave like this, another one is what, particle in nature. Particle means what, this is try to understand a bullet, okay, not a gun, okay, bullet. I am talking about a bullet. Bullet move in a straight line. Bullet move in a straight line. That is why light is having a dual property. One is a wave, another one is what, particle. Another one is what, particle. This is the what, basic. Okay, that is why these 2 points are most important. I am going to remember one more point. Up to this atomic structure or structure of atom, up to this means not this class, last class. Up to last class what I told, that is fully basic, that is not there in your syllabus according to what, PU board syllabus, means due to COVID, that is why the up to Thomson model the syllabus was what, deleted. Okay, that is most important point, but what I told, because of what, basic, we know compulsory basic, without a basic next point you are not going to understand. Who discovered the proton, who discovered the neutron, who discovered the electron, that is not there, but it is there in a what, NCERT syllabus. Due to COVID PU board has deleted the syllabus, bear in mind. Okay, don't worry about those points, but those points are important. That is why you have to practice those points also, no problem. Otherwise you have to start from here. If you want to prepare in theory exam, you have to start from here. Okay, just here, wave nature of light, in this case what, electromagnetic radiation. In that point, 2 points, one is wave, another one is a particle. The first point is clear, the light is having a dual property, wave and particle. Okay, this is what indicate wave. Just see here in this case, in upper side is there, no, in this case what you are going to call, these are what, crust, these are what, crust. If lower side is there, no, this is indicate what? Trough. What you are going to call, that is indicate what? Trough. T-R-O-U-G-H, trough. Okay, this is one crust, this is called what? Trough. Just here in this case, they are going to take a light, after that they are going to apply what? Electric and magnetic field. When they are going to apply electric and magnetic field, the light waves start oscillating, oscillating. Just here they are going to take a what? Light waves. The first point here is electric field. This y-axis is there, no, electrical field. This x-axis is having a what? Direction of propagation. Means wave moving like this, means we are going to call a what? Direction of propagation. Another point is there, that is what? Magnetic field. They are going to apply the electric field. This first ray is there, no, this one is this ray, this wave is there, no. Okay, this wave is indicate what? Electrical field. When you are going to apply the electrical field, the wave is going to form like this. Okay. If you are going to apply the magnetic field, this is there, no, this wave is indicate what? When you are going to apply the magnetic field. Okay. Electrical field and magnetic field, these two having a what? Direction of propagation. Okay, that is what most important. Who discovered all the things? Maxwell. The name of scientist is what? Maxwell. Okay, here is there, no, I wrote for notes purpose. Maxwell was first to reveal that the light waves are associated with what? Oscillating electric and magnetic field. Just now I explained. Okay, this is important. Next, after that, in this case, this is a look like a what? Right hand rule. It is there in, I think, 10th class. Right hand rule is there, no. That's why in this case important. This first one is there. This is indicate what? You have to think. If you want, you can do like this, no problem. Okay, it is clear. This first one is there, no, this first one is there, that is what? Electrical field. This one is indicate what? Direction of propagation. After that, this one is there, no, this one is there, no, this is indicate what? Magnetical field. These two are what? Mutually perpendicular to each other. These three, not two, these three are what? Mutually perpendicular to each other. That point I wrote here. Okay, notes purpose. Electric field, magnetic field and direction of propagations are mutually perpendicular. It is a look like a what? Right hand rule. It is a look like a what? Right hand rule. Okay, that is important. Okay, this is in theory examination, they are not going to ask, but better you have to understand the things. It is a totally what? Electromagnetic radiation. That is indicate what? Wave nature of light. Okay, that is what? Important. Okay, next point is what? The fundamental characters are there. Fundamental character most important. Okay, this basic knowledge, it is used in what? PVC second year also. Okay, that's why the fundamental characteristic of electromagnetic radiation. Okay, electromagnetic radiation. Okay, just here in this case, the first fundamental is what? Wavelength is there, frequency is there, velocity is there. Next one is what? Wave number. These four are indicate what? Fundamental characteristic of what? Electromagnetic radiation. The first point is what? Wavelength. The wavelength is represented by what? Lambda. How we are going to write? This is the lambda. This one is indicate what? Lambda. Here is there, no, like this. This one is what? Lambda. Okay, this one is indicate what? Lambda. Okay, no problem. Just see, wait. This one is indicate what? Lambda. That is what? Wavelength. Okay, just see here. In this case, what is wavelength? I am going to explain here. This is the what in examination PU board they are going to ask you what is definition of wavelength, otherwise define wavelength. Okay, that's why in this case make it practice. It is the distance between two successive. It is the distance between two successive trough or a crust, that is indicate what? Wavelength. Very simple definition. It is the distance between two successive crust. Next one is what? Trough in a wave. Just see here. Okay, try to understand the things. Just here in this case, this is indicate what? Crust. These two. Okay, these two indicate what? Crust. This is the difference between two successive. Successive means this is indicate what? Successive. If for example, just see here, in this case wave is there like this. Like this. This is not a successive wave. There must be a what? Successive like that. It can go up, next it can come down. Okay, just here in this case, the difference between two successive crust or a two successive trough, here is there, no, this is indicate what? If you want, you can write upside like this. Okay, this distance is what? Lambda. The definition is very simple. It is the distance between two successive crust or a trough in a wave, that is called what? Wavelength. This is what you are going to call. This is indicate what? Wavelength. Try to understand, when you are going to consider a wave, that wave having a what? Successive, in that difference is the most important. For a trough or a crust, you have to take any one of. Okay, definition. Next one is what? It is expressed. Wavelength is expressed usually in what? Nanometer. You have to write small n and small m. That is what? Nanometer. 1 nanometer. Otherwise, just you have to, in this case what? At least 1 is there, no problem. 1 nanometer is equal to what? 10 to the power of minus 9 meter. Bear in mind, important. 1 nanometer indicate what? 10 to the power of minus 9 meter. Nano means very small. You have to write 0.0090. After that you have to write what? 1. That is indicate what? 10 to the power of minus 9. If you want 10 to the power of minus 9 means what? 0.0000. Okay, you have to write 90. You have to write. It is very small. You know very well about that nano car. Why the name kept a nano? Nano means what? Small. The nano means what? Small. Generally mentioned, expressed wavelength in a nanometer, but SI unit is a standard unit. Okay, another only unit is that is CGS system. I think you have studied in first topic. Okay, that is some basic concept. In that it is there, SI unit, CGS system. Okay, but SI unit is a what? Meter. The SI unit wavelength for what? Meter. Next question, conversion is the most important point in this case. Conversion means, I am going to explain here conversion. I think it is visible. Okay, just see here. In this case, just I am going to write like this, 10 to the power of minus 9 is there. Otherwise, I am going to take a directly 1 nanometer only. 1 nanometer is equal to like this. They are going to ask you 1 nanometer equal to 10 to the power of minus 10. Otherwise, directly I am going to write a 10 angstrom. No problem. Is it possible conversion like this? 1 nanometer equal to 10 angstrom. Okay, such kind of conversion they are going to ask you, but you know the conversion is a very simple. Okay, I am going to explain here only. Okay, 1 nanometer equal to 10 angstrom. How 10 angstrom will come? Okay, that is I am going to explain here. Just here I am going to write 1 nanometer here. 1 nanometer means what? 10 to the power of minus 9 meter. No problem. Okay, next in this case I am going to multiply. Just I am going to write a meter, multiply by 10. Next I am going to write a divided by 10. Just here, this 10 get cancel. Okay, automatically this 10 get cancel. Automatically 1 nanometer equal to what? 10 to the power of minus 9 meter. No problem. Next, after that, do one thing. This 10 will go up. Okay, in this case what happened? If 10 is there, no? In this case what happened? It can go up means what? That is a minus. That is what? Minus 1. In this case minus 1. Here is there what? 10 to the power of minus 9. Into what? 10 to the power of minus 1 means what we are going to get? 1 nanometer equal to 10 to the power of minus 9 into 10 to the power of minus 1 into 10. Just here 1 nanometer equal to 10 to the power of minus 10. Next one is what? Into 10. Okay, 10 to the power of minus 10 is 1 angstrom equal to 1 angstrom equal to 10 to the power of minus 10. Okay. Here is there, no? This 10 to the power of minus 10 indicate what? 1 angstrom. 1 nanometer equal to 1 angstrom means just I am going to write a what? Angstrom. 10 I am going to write here. Next, this one is what? Angstrom. Such kind of conversion they are going to ask you. Such kind of conversion. Okay, nanometer converted into millimeter, and next millimeter is converted into 1 nanometer, micrometer. Okay, femto. 1 femto means what? That is 10 to the power of minus 15 is indicate femto. How we are going to call femto? 1 femto. Just I am going to write a fm, small fm. Okay, that is indicate what? 10 to the power of minus 15 meter. That is indicate what? Femto. I am going to write femto. Okay, like this. Okay, is it clear? Okay, such kind of conversion they are going to ask you. This all such kind of conversions you have to solve with the help of first topic. Some basic concept topic it is there. Okay, all the conversion. Okay. Most important. Okay, is it clear? Wavelength means what? Very simple, the distance between two crust, successive crust or a trough in a wave, that is indicate wavelength measured in a nanometer. Okay, if you want you can take a screenshot for notes. I will count 5. Okay, 5, 4, 3, 2, 1. Okay, is it clear? Okay friends, listen here. The next second point, the first point is what? Wavelength completed. Wavelength means what? That is the distance between two successive trough or a crust measured in nanometer. That point completed. The next one is what? That is velocity. The velocity is represented by what? C. The velocity is represented by what? C. Definition of velocity is very simple. It is the distance. Most important point. It is the distance travelled by a wave in 1 second. It is a distance travelled by a wave in what? 1 second. That is called what? Velocity. Just here try to understand the things. Okay. I am going to write like this. Okay. Just I am going to represent a wave. Just here. I am going to start time. Okay. The wave start from here. I am going to start time means 1 second. How much distance it is covered? That is what? Velocity. Here is this point. Okay. I am going to start time over. Okay, this is 1 second. Within 1 second, this distance is there. How much distance is covered? Okay, this distance is called what? Velocity. This distance is called what? Velocity. Definition very simple. Okay, that's why it is a distance. Try to understand definition with the help of diagram. Okay, it is a distance travelled by a wave in 1 second. This is a wave. Up to this 1 second, time is over. Okay, this is what? Velocity. The distance travelled by a wave in 1 second is called velocity. Okay. Next, all electromagnetic radiation. Electromagnetic radiation means it is a type of electromagnetic waves. Electromagnetic waves. All electromagnetic radiation travelled with the same velocity, that is 3 into 10 to the power of 8 meter per second. The velocity is measured in meter per second. This is the, very well about that. This is the what? All electromagnetic light is also having a measured in what? Meter per second only. 3 into 10 to the power of 8 meter per second in air or vacuum. Vacuum means what? There is no air or a gas. Vacuum means what? There is no air or a gas. Okay, that time also measured in what? Meter per second into what? That is value is what? 3 into 10 to the power of 8 meter per second. They are going to ask you what is the value of C. That is velocity of light we call, no. That is what? C value is 3 into 10 to the power of 8 meter per second. This is compulsory. Bear in mind, it is used in what? Calculation part. This value is used in what? Calculation part. That's why bear in mind. Okay, very simple definition is there. Okay, it is a distance travelled by a wave in 1 second, that is called velocity. All electromagnetic radiations travelled with the same velocity. That's why just you have to remember this point. Okay, okay, is it clear? Velocity is over. The next one is frequency. The frequency is represented by what? Nu. What you are going to call this is nu. Okay, that is the lambda. This is a C. This is a nu. In this case, what? It is the number of waves which pass a given point in a 1 second. It is the number of waves pass a given point in a 1 second. Okay. Next, try to understand this one. I am going to explain here only. Better I will write here only. Where is it visible? Okay, just here. In this case, okay, just here. According to definition, it is the number of waves which pass a given point in a 1 second. Just here I am going to mark this point. Okay, the waves start from here. I am going to start a timing. I am going to start a timing like this. Time over. Okay, in this case, how many waves passed? 3 waves are passed in a 1 second. That is what? It is the number of waves. Most important. That is different. That is distance travelled. But this is what? Number of waves which pass a given point in a 1 second. Okay, I mark this point. Don't worry about that. The next one. Up to this mark is important. How many waves are passed in that mark means totally 3 waves are passed in a 1 second. That is analogy. Don't think like that the waves pass only 3, not like that. Just our understanding. It may be 4, 5. It is depend on what? Experimental things. Okay, just for our understanding. In this case, what happens? This is 1, 2, 3, 4, 5, 6, so on. 1 second. Depends on what situation. That's why it is the number of waves which pass a given point in a 1 second. That is number of waves you have to calculate. How many waves are passed? That is indicate what? Frequency. The velocity is different, wavelength is different. Okay, that is why the frequency is expressed in per second or a hertz. okay, per second or a what hertz. Okay, well, this one is measured in meter per second. Wavelength is there, no, that is measured in nanometer, SI unit is a meter. Next, after that, combination of these three, there is generation of one formula, velocity, wavelength, frequency are related by the equation C is equal to nu into lambda. Velocity is equal to what? Frequency and wavelength. The velocity is what? That is the distance between the what? Number of waves, and next one is what? That is the difference between successive trough and crust. Okay. If you want nu as it is C divided by lambda, you have to modify this formula. Okay. That is why most important formula C equal to nu lambda, otherwise you have to write nu equal to C by lambda. Okay. Up to this, friends, wavelength, velocity, next frequency, these 3 points are most important. Make it perfect. Okay, make it perfect means what? You have to write definitions and write values. Next, write what? Unit. That is most important. The next one more is there, that is wave number, and some problems are there. We will discuss next video. Thank you, friends.